G'day, welcome to Tech Math Channel. What we're going to be having a look at in this video is another false proof where I am going to show you this time the following, that 2 plus 2 is equal to 5. Okay, so obviously you know that 2 plus 2 doesn't equal 5, so probably what I'd really hope for you in this video is you try to spot where I insert the lie. Okay, so let's do this. I'll get rid of that, give us a bit of space. So I'm going to start out with the following idea, that we have negative 20 and it's equal to negative 20. Okay, pretty good so far, nothing wrong here. The next thing I'm going to do is I am going to change these around, basically so we have two equivalents of negative 20. The first one on this side, this is going to be 25 take away 45. Okay, 25 take away 45 is negative 20. And this one here is going to be 16 take away 36. Alright, the next thing I am going to do is I am going to rewrite these a little bit, because 25 is equal to 5 squared, and negative 45 is equal to negative 5 times 9. 16 can be written as 4 squared, and negative 36 can be written as negative 4 multiplied by 9. Alright, nothing wrong so far, eh? The next thing I'm going to do is I am going to add 81 over 4 to both sides. Okay, I'm going to add 81 over 4 to both sides. So this side of the equation, if I do that, is going to equal 5 squared minus 5 times 9 plus 81 over 4. And this side, to keep it nice and balanced, I'm going to do the same thing. This is going to equal 4 squared minus 4 times 9 plus that same amount, 81 over 4. Now what I'm going to do is I am going to factorise this equation. I'm going to put it in brackets. I get the following. I am going to get 5 minus 9 over 2, and this is squared, and this is equal to 4 minus 9 over 2, and this is squared. Alright, don't know if you've seen a problem yet. To this sides now, both sides, I am going to square root it. We have this squared, we have this squared, this is equal to this squared, so basically it would make sense if I was to say, okay, I'm going to square root these. This is 5 minus 9 over 2, and this is equal to 4 minus 9 over 2. Then what I'm going to do is I can cancel out both of these. I can cancel out the negative 9 over 2, and I can cancel out this negative 9 over 2 by adding 9 over 2 to both sides. And if I do that, I am going to end up with 5 equals 4. And this, as you know, is equal to 2 plus 2, so 2 plus 2 is equal to 5. Alright, so did you spot where the lie was inserted there, where the problem was? Go through my working out, see if you can spot it. Okay, I will tell you where this lie was, where the fallacy was right now. So the fallacy that was inserted is to do with positive and negative roots. Okay, and what this means is this. Basically, at this stage, at this particular stage here, this is where the problem is, where I go from this step to this step, and I square root. And what I have here is I have this squared being equal to this squared here. I'm going to represent that here as a squared being equal to b squared. Okay, this squared, a squared, is equal to b squared, this one here. The problem that I have here is it's only true if a is equal to negative b. Okay, so basically what this is saying is you have to be very careful occasionally when you are taking the square root of both sides of the equality. And if you don't do it correctly, what you can end up with is a false proof. So at this particular step here, we've assumed that basically I've taken it down so this has become positive and this has become positive, you know, a equals b and everything's good in the world, right? But this is not the case. So I'll show you the alternative that would occur if I assume that a is equal to negative b at this particular step here. What would occur would be this, and I'm just going to move it up a little bit just to give ourselves a bit of space. So if I'm saying that a equals negative b, well, at this particular step as I went from here to here, I would have 5 minus 9 over 2, okay, as I square rooted it, and this would be equal to, instead of just being 4 minus 9 over 2, this is going to be negative, and I'll put that in brackets here, 4 minus 9 over 2. Okay, that's a 9 there. And if I was to do this, I'll expand this out now. This would be equal to, okay, this is going to stay as 5 minus 9 over 2. This would become equal to negative 4 minus times a minus is a positive, so plus 9 over 2. Give myself a bit more space. Now to both these sides, what I'm going to do is I am going to get rid of this 9 over 2 by adding 9 over 2 to both sides. 5 is equal to, because I add 9 over 2, it's just going to cancel that out. And this is going to be negative 4 plus 9 over 2 plus 9 over 2. And just a bit more space. So this is going to be equal to, so 5 is going to be equal to minus 4, which is plus 9 over 2 plus 9 over 2. So the minus 4, 9 over 2 plus 9 over 2, that's 9, half of 9 plus half of 9, which is going to be equal to 9. And then what we'd have is 5 is equal to 5, and this would be correct. And so, as you see here, this is one of these types of fallacies where this squaring only, the square rooting here only works if we know that A is equal to negative B. Okay, so it's a squaring fallacy, a square rooting fallacy. Anyway, another type of proof here. So just another thing to be careful of. Once again, I think these are really, really good because, they show you what to look out for when you're actually doing various operations in maths. So tell us what you think of that one. A little bit messier, this one, okay, but I think a really, really valuable one to look out for. Tell us in the comment section what you think. Flame me if you want. Anyway, see you next time. Bye.